All right, guys. I think we're going to go ahead and start. All right, everybody. Welcome to the Portland PowerShell user group. My name is Bill. I help run the group along with Juan, who's controlling the presentation. We're going to switch up the format just a little bit from what we usually do. We're recording this presentation because we have our guest speaker that I'm about to introduce. But we're going to mostly launch kind of right into the recording as opposed to what we usually do, which is a bunch of intros and that kind of stuff. Just so that when people watch the recording later, they don't have to fast forward through quite so much stuff. But don't worry, after the presentation, and we'll have a little bit of QA time, we'll go ahead and do our own intros to each other, and we'll do some PowerShell wins, and we'll do some all that normal kind of stuff. Just keep in mind for the people that haven't been here before that that's the kind of stuff that we'll do front-loaded, and then we'll do a presentation, right? So with us this evening, we have Mr. Steven Murawski. He's a developer advocate with Microsoft. I'm going to let him give his own, most of the rest of his own bio, but we're really excited to have him today, and I hope everything goes well.
Me too. So let's see here. Let's see how this works. Can you guys hear me all right? All right. Cool. So as Bill mentioned, I'm a developer advocate at Microsoft. That's a new role as of like about a year ago, and so it's a re-engagement with our technical audiences. And it says developer advocate. It's really technical advocacy. So one thing you might notice now at Microsoft is this move to docs.microsoft.com, away from TechNet and MSDN. We no longer have this arbitrary IT and dev divide on technical documentation. Because number one, in our technical roles, we all have some scale of, well, some of the work I do fell on the MSDN side of things, some of it fell on the TechNet side of things, and now I got to jump all around to find stuff. No, you need technical documentation, you need technical information to get your jobs done. What you classify as, who cares, right? So I'm a developer advocate, but really it's technical advocacy. And what that means is I'm here to help empower you guys do stuff on Azure, but more importantly, do stuff and be awesome in your environments. And on the flip side, I'm supposed to take the stuff that you guys tell me is hard to do with our stuff and go back to the product teams and help them make the products better for y'all. So I do have one ask of you guys is if you see something that's hard, if you're trying to do something and you can't do it, contact me or one of my teammates. Twitter is the easiest way to do that. I'm at Steven Murawski on Twitter. You can also use, I actually should have had it on this slide, but I don't. I will put it up there later. My team has a hashtag. It's the hashtag LOECDA. It's League of Extraordinary Cloud Developer Advocates, or DevOps Advocates, which started off as a joke and now became a hashtag and a website, and now it's in marketing materials. And thing I learned is don't make a joke to Donovan Brown because he'll just run with it. It started with a DM that I sent him as I was interviewing, and yeah, just it went a little too far. So, all right, tonight's presentation.
9, 1, 6.
So what I'm going to talk about tonight is I've entitled it "Slow is smooth, smooth is fast." That is a phrase that I learned from one of my firearms instructors back when I was in the police science program. So just a quick little bit. Are you focused on the? It was doing it before. Oh, here we go. Or did you do that? Okay, no, I got it. All right, so just a quick history. I'm on my third career here. I went through a couple different things, but when I got into IT, I was working at a police department. Before I got into IT, I was going to school to be a cop, working as a clerk and dispatcher, and that's where I got into firearms training, and that's where we're going to learn a little bit more about what that phrasing actually means. But we're really going to talk we're going to start the foundation of change and automation. These are some core topics to how we manage our environments today and where we're going to be managing them as we go forward. Now, if you come from like an ITIL background, change means something, right? You might have change boards, you might have change review meetings. If you run, how many of y'all are operations personnel and run environments, right? More developer-y types? Okay. So from the operations side of things, when developers give us new versions of software, that's change, it breaks things, and we get in trouble, and it's just badness. For developers, when the operations folks apply new security policies and things, and it breaks your applications, and you all get in trouble, that's change. It causes pain. And we've learned that change equals pain. So to me, our environments are kind of like this game of Jenga, right? And so they're this game of Jenga, and every change is moving one of those blocks. And our environments get more and more brittle, more and more are closer and closer to falling over. Yeah. There's a patch going out. Oh, and yep, new software deployment. Everything's down. So what do changes look like? There's a lot more things than what you might think of that go into changes. And this is just a couple of things here. But guess what? When our logs fill up and we go and blow them all away, that's a change. That's a change to the operating environment. Because guess what? Some stuff stops working when your logs fill up. Surprise, huh? Emergency patches. How many people have deployed software before? All right. How many times has that gone perfectly? Right? Yeah. Right? And sometimes you don't know it hasn't gone perfectly if you've deployed it in a maintenance window, smoke tests come out all right, until people start using it. And guess what? When data's getting messed up or customer data's getting lost or people can't do their jobs, all of a sudden it becomes really, really important to sidestep all those change control processes that we put in place and all those deployment guides and things that we have to get that emergency patch out right away. And so we have a couple of different paths that we take to getting change out in the environment. Sometimes we go the nice standard route of, okay, new patches are out. Let's update the WSUS server. They're going to roll out over the weekend. We'll come in Monday. Everything will be broken. Things will be fine. Or we have our deployment during a maintenance window, or we have these emergency patch scenarios, right? And they all have different levels of accountability. They all have different levels of urgency, and they all follow different process. That doesn't give us a very good time, right? Because that's what leads to this kind of fragile infrastructure that's going to fall over, because we're not following the same pattern. We're not able to test the way that we do these things because we do them in such a haphazard way. And it's not haphazard by intention. It's just haphazard by the way that things just kind of work themselves out. So just kind of been talking about this a little bit, but changes tend to fall into kind of two different general buckets. The first is kind of standard changes, and we have usually some kind of review of those. Maybe we've tested them in a test environment. And then we have our emergency changes. Like I said, that emergency patch that we just got to get this thing out. The recent Intel vulnerabilities might have led to some emergency changes, right? As we push out patches a little faster than we might normally have, and then some things stop working. And I know there's pizza. We'll pause in a second. So standard changes, right? And emergency changes. Emergency change there, I'm thinking that's going to topple. Right? So that leads me to automation. What happens if we can start making all of our changes kind of happen in the same fashion? And whether it's an emergency change, whether it's a standard change, we can go through the same pattern to apply them, whether it's a software deployment, a patch update, clearing logs, making sure that we've got the right website set up, whatever the changes are. What if we could use some kind of tooling to get us to that place, right? So there's a couple of reasons that we want to automate these processes. First, we want to serialize our tribal knowledge, right? Have you guys heard the term tribal knowledge before? So the general idea being that, Brandon's worked at Columbia now for X number of years. And so there's things that he knows about the environment there that newer people may or may not know yet. And they're stuck in his head. And so one of the benefits of going through and automating a process is we've now taken that out of Brandon's head, put it into a script, put it into a config management document, put it into something that's other than a Word document or a Markdown file that's going to become stale in no time flat. We put it into an executable format that persists that knowledge so that anybody else can pick that up and use it. And we also have operational intuition. How many times have you been in an environment where you're troubleshooting a problem and somebody says, I know it's this? And they know it because they've had that time in the environment. I was working at Stack Overflow, and there was a guy there, Nick Craver. The guy has like perfect recall and is really smart. And he's been at Stack Overflow since almost the beginning. So he has really strong operational intuition about what may be going wrong in the environment just by looking at performance data coming off of like the web tier and the SQL servers. You see a little CPU fluctuation, and he can probably give you a pretty good idea of what the problem is. Now, that didn't help me when I was new there and an alert goes off because I'm not as smart as him. I don't have the recall he has, and I don't have the time in the environment. So if we took and were able to serialize that knowledge into our alerting system that could provide that information, we've now automated the transfer of that information in an executable fashion when it happens, right? So the next major area that we spend with our automation is to amplify our effect, right? You can only be in so many places at once, typing so many command lines at one time, clicking through so many UIs. Automation is a way to scale yourself and your team, right? It allows you to amplify your impact across a broader range of targets, across a broader range of times. It can even work when you're not present and you're out on the beach, right? And the last major benefit that I see for automation, right, is to reduce the time it takes to get something done, right? If I run a script, that script is probably going to execute a lot faster than if I just sit there at the command line and type those commands if I can recall them perfectly, right? And as I mentioned, I don't have perfect recall, so I might be Googling around or digging around for the script that I wrote this in, 30 times before. And if I've got that automation in place, ready to run, I can resolve situations a lot faster, accomplish tasks a lot faster than if I'm doing them in a one-off fashion. Does that all make sense? We're all on the same page, we're ready to move forward? Cool. So, when we look to start automating our process, we're going to focus on a couple of goals: consistency, resilience, and repeatability. Now, get a picture? All right. Those are the things that we're going to try to get out of our automation. Now, where do things sit today, right? What I've seen, and your environments may vary, but what I've seen a lot of in many of the environments I've been in, see a lot of ad hoc scripts. That's a positive, at least, that we've got some stuff written down. The things are very tactically focused. I have X script to tackle Y scenario. I have Z script to tackle D scenario, right? And not necessarily a lot of libraries of code for tasks that we normally do a lot. We're moving that way, but right now there's still a lot of tactical ad hoc scripts. There's very little testing. Who here's played with Pester at all? All right, handful of folks. Testing is extremely important, especially when we start talking about scripting in our environments. Normally when we talk about scripting and automation in our environments, we're talking about things that change system state. When we change system state, we can potentially take servers offline, stop services from running, right? So the most well-crafted code that's going to run to help your customers or internal teams or anything like that can be taken offline with a bad script, right? And if we're not testing in a test environment and we're not writing some unit tests and functional tests, we drastically increase the risk that something might go wrong with our script. And if we're manually testing, we're spending a lot of cycles doing things over and over and over again when we could be letting computers do that work for us, right? I heard, and so this will be told like third hand, I heard Jez Humble relating to the hosts on .NET Rocks about a quote from Neil Ford, which was, so really you're really getting this third hand. But basically, the gist of it was, you know, when humans do the work that computers should be doing, computers get together at night and laugh at us, right? And so the more automated testing that we can build for our automation gives us a higher degree of confidence that things are going to behave the way we expect them to behave. The last thing I've been seeing a lot of is there's a lot of interest in moving towards infrastructure as code. And now I'd even say, because the stack is starting to get a little older, there's also a lot of interest in moving towards containers and platform as a service and stuff like that. But we're starting to see a more of an interest in actually defining our environments in an executable format. And that could be ARM templates, that could be DSC, that could be Chef, that could be Puppet. And there's a lot of different options there. Somebody gonna say something? Okay. So we're gonna take a little digression, just a cautionary tale. Who's heard the slogan, automate all the things? Who likes that slogan? All right. Automate all the things can be a very dangerous slogan, right? We want to apply our automation with intention, right? If we automate all the things, we can end up with a little Rube Goldberg type contraption. So the danger that we face when we automate all the things is automation can take some of the pain out of things. Some of the pain exists because we're doing something we shouldn't be doing. Right? So it's when you go to the doctor and you say, hey, doctor, it hurts when I go doing this, when I do this. The doctor says, don't do that. Right? The idea is we want to apply automation where we're going to get the most benefit from it and that it makes the most sense for the work we're trying to do. So when we look at the flow of work, right? Imagine this little pipeline here is the flow of work through your organization. And we're going to start out with, we're defining something, we're defining some requirements, and we got a bunch of people who are waiting there to take that and go spin up some VMs. And then we have the one network guy who's going to open the firewall ports for us, right? Then after that, there's some other processes. Maybe we get some application deployment happening. Maybe we have some load balancer work going on. And then towards the end, we have our QA folks waiting for stuff to test. In that flow of work, what is our constraint? What's going to hold us back? Is it going to be our guys defining the new jobs, the people spinning up VMs, the network guy, our software deployment? Okay. What do you think is going to define how quickly work gets done in our organization? It's going to be the network guy. It's going to be the network guy. In this case, right? Not all cases, but in this example, it's going to be the network guy, because we can only get so much work through there. So no matter how fast B goes, they're only going to be able to process as fast as, there's only going to be enough work coming through that C can handle, that our network person can handle. So you can't get to doing software deployment until you can reach the VM. Can't reach the VM until the network guy puts it on the network. And so nobody else past that C point can really do anything until C works on it. No matter how fast A and B work, C will only work as fast as they can handle, right? So when we look at where should we automate in this pipeline, if I automate things and make my VM deployment go a lot faster, have I actually accomplished anything? No. If I write a bunch of scripts to automate our QA process, have I made things better? No. You might have made things marginally better for that particular environment, but they're always going to be starved of work. That's why they had time to write the scripts, right? But unless we focus our efforts on that constraint, on the part of our workflow that is the bottleneck that's slowing the work through the system, all that other automation effort is worth a lot less. Right? I'm not going to say it's worthless, but it's worth a lot less. Because we are not, the idea here is we need to think of the system as a whole, not just our little view of it. So when we look at automate all the things, we need to step back and look at the total flow of work through the system. We need to look, is this even a process we should be doing? Once we've determined that, okay, let's find out where our constraints are, and let's try to make them as productive as possible so that, guess what, maybe we expand the capacity of the network guy really, really good, and now our software deployments become the next bottleneck, and that becomes our next target. This is a process that does not stop, but we need to be careful that we don't just focus solely on the thing that's right in front of us, because that's the pain we're seeing, and look at the situation as a whole. So how can we bring that change process and automation back together? Okay, cool. Watching the WebEx news, taking a second to update. So the peanut butter and banana thing actually came out of some comments from people at PSConf Asia. I don't actually have an opinion one way or the other on peanut butter and banana, but some people there did. So that's okay. So now we're going to get on. Now we're going to get to kind of the title of this talk, and slow is smooth. So back when I was in the police science program, and we were in the firearm class, there's a little bit of trepidation amongst the instructors, because they're handing firearms that are loaded to a bunch of people, many of whom have never handled the firearm before. So we went through a lot of drills, both with loaded firearms and without loaded firearms. But the idea being, we were going to train in a number of processes, one of them being how to draw from a holster safely. And the idea was to go very, very slow until you got a nice, smooth behavior. Because if you're going to rush, you start getting all fumble-fingered, you end up, having your firearm pointing towards your buddy. Just a lot of bad things can happen, right? So you start out really, really slow. And by going slow, you build up the muscle memory, you build up the feel for it, and you start getting smoother. You start getting comfortable with the process. And when you start getting comfortable with that process and you start working out the kinks in it, that's when you get yourself to the place where you're going to be ready to start speeding up. So when we start talking about continuous delivery or CICD or any of these concepts, and you start talking about DevOps workflows, and you hear all the vanity metrics, hey, Amazon's doing thousands of deploys a day, and these people are doing hundreds of deploys a day, and 10 deploys a day, or whatever the number is, right? It is not about the number of deployments a day. It's about the core of this is understanding that flow of work that we talked about. What are all the steps that we need to accomplish this? We need to identify the criteria that we have for success so we can write some automated tests, because anywhere a person has to go validate is going to slow us down and add variability into the process, right? We want to bring that variability out. Because computers are going to do the same thing every time, unless you're throwing in like a random function, right? Which you probably don't really want to do unless you're doing some kind of fuzzing testing or something. But we want to do things the same way every single time. That's why we're automating. We're putting down the steps in order that we want them to do. So then we want to identify that criteria for success so that we can write some automated tests. Once we've got the basics down, we've built up that muscle memory, we've got that workflow, we've validated that workflow with our tests. Now we can start looking to speed up. And we only have to speed up to the point that our business needs require. It's not about X number of deploys a day. It's about being able to deploy changes when you need to. Right? That could be once a day. That could be once a week. It could be once every 15 minutes. But it could also be when that emergency patch comes down, when that 0 day is announced, when Intel decides to have another issue, or when we get another vulnerability in Bash, or we get another vulnerability in Windows XP. Whatever that scenario is. Right. If we can deploy our change through a standardized fashion that goes through automated tests and deploys when we need it, and we know we've built up that muscle memory, we know we can go fast, and we know it's going to be done right, we've now reduced the variability of injecting that change into our environment. So instead of playing Jenga, we're going to be playing a much more stable game, and I'm drawing a blank now on what one of those might be. I probably should have thought about that a little bit more before making that another analogy. But you try things, right? That didn't work. But once we can deploy on demand, we also enable a couple other scenarios. Maybe you're deploying to physical infrastructure now, or to on-premise virtualization, but you want to experiment with blue-green deployments. Now we can, with minimal effort, there'll be some, but with minimal effort, maybe create a similar build that targets Azure or AWS or Google Cloud, right? Where we can just spin up whatever infrastructure we need and start testing these kind of scenarios. Because we figured out what it takes to get our environment to look the way we want it to look. Now it's just a matter of repointing it somewhere else. And now we can start experimenting and trying new things. And the cost to that experimentation drops dramatically. So, who here is using some sort of CIACD process? And I'll acronym police myself here. CI, continuous integration, most often found in like a build server. build servers and orchestration server that knows how to talk to source control. And then continuous CD, I'm using it as continuous delivery. Continuous delivery is that our code is whatever's in our source control is always in a releasable state. And I'm vastly oversimplifying here. It's always in a releasable state. And we can deploy when we want to. So we got 1, 2, 3. Good, we've got a lot of folks. All right, awesome. So for those of you who are not doing that yet, and for any who may stumble upon this recording, where can we start? You want to keep this as simple as possible to get started. So we're going to start with source control, and we're going to start with a CIACD tool. And here's some more acronym policing. There's another CD that you may hear, and actually there's a lot of people at Microsoft who love to use this CD because it feels cooler for them, and that's continuous deployment. Continuous deployment is everything that makes it through our CI/CD pipeline actually gets deployed out to some environment. Now, you may notice something. Continuous delivery depends on continuous integration. Continuous deployment depends on continuous delivery. So these concepts build on each other. The one we really want to shoot for is that continuous delivery. You can step up to continuous deployment if that's a need in your environment, but continuous delivery is the target we should be shooting for. We want to make sure we have a nice stable version of things in our master branch. We want to make sure that when we need to deploy that, we can. And there's a number of other practices and patterns that kind of go around continuous delivery we can talk about offline. There's a really good site on trunk-based development and all sorts of other stuff that you can dig into. But the core idea that I want you to take away is that we always want to make sure that we're ready to deploy when we need it. So back to the getting started idea. So what's the workflow then that we have when we're starting to introduce this? So we've got a source control, something for source control. You can use anything you want as long as it's Git. And I made myself laugh, and it's half the battle. And we need some sort of CI/CD server. There's lots of free or low-cost options here. VSTS is free for up to 5 users. There's a free on-prem TFS. The Jenkins, the TeamCity's got some low-cost versions or free versions. There's a lot of different tool chains out there that you can get for this at very minimal cost. GitLab has an option. So cost should not be a factor in this. So the first process that we want to start looking at is we take all the scripts that we have, every config file we can find, and we stick them in source control. And in order to kind of make this process a little stickier, is you want to have a dedicated admin point where this stuff is going to get put. And that's where you want to run your automation from. And that's going to become important a little bit later. But then we just have no other steps. We just have that CI server, watch that repository, and when it sees changes, it dumps them out onto that management point. And it can be management points in different environments. The specific details of what that management point looks like is up to you. But the idea being, in order to get automation available in our production environments, in our dev environments, our test environments, we want them to have been put in source control first. So we build up that muscle of using source control, right? So we start using our automation. We find, hey, we need to change something. We change it. We put that change into source control. And source control puts that back out into the environments where we need it. This gives us the foundation to start building in some quality. to this automation, these tests, or these scripts, right? So now, once we're comfortable with this, and this may take a while, for people who haven't been using source control in their environments, it can take a little getting used to. And wrangling all the different automation scripts and things that you're using, you might have to find that script on that file share. You know the one, right? Not that file share, but the other one. And finding all those things, getting them into source control, getting them in a place in a way that's usable out on that management server. When we're ready to take the next step, we're going to add one little step. Oh, that doesn't really show up on there. So that one little step we're going to add is we're going to have the CI server run some tests. And what kind of tests, you may ask? Well, we have syntax checks. Is this even valid PowerShell? Given this is the PowerShell user group, we'll focus on PowerShell scripts. Is it valid PowerShell syntax? Will this thing even run if I try to call it? Lint, PS Script Analyzer. Guys heard of it? PS Script Analyzer is a it's a project from the PowerShell team that's open source, and it's a linting, it's a linting tool. It will look for some common problems in your scripts, give you suggestions for fixing those things like you're using aliases in your script, and do a little finger wag at you and tell you to go change those things. You can control some of the behavior of how those checks happen, so you can come up with a way that is going to be consistent across all the people that are going to be using those scripts and changing them so that you have a consistent, kind of a consistent editing experience. Unit tests. This is where Pester comes back into the game. Oop, jumping ahead. This is where Pester comes back into the game, and we start testing the behavior and the logic inside of our scripts. Not the behavior, the logic inside of our scripts, to make sure that when we call it with a certain set of parameters, it's going to try to do the things that we expect it to try to do. Now, you don't have to add all of these types of tests in at once. You could even just start with a nice simple syntax check, make sure everything's going to be valid before it gets out. PS Script Analyzer is a low overhead one to add. Unit testing takes a little bit more because you got to learn a little different pattern for writing your scripts. You're learning a different tool, Pester. Once you're comfortable there, you can also start adding in some integration tests. What happens when we spin up some infrastructure to run these scripts against, and let's test and make sure that it did the things we expect it to do. This really comes into play when you start looking at configuration management. If you're going to be doing DSC or Chef or Puppet or Ansible or any of these type of tools, some sort of integration testing is going to become vital. Because I don't know about y'all, but for me, configuration management's scary. The idea of an agent that's sitting running on my servers, that's waiting in the background to change the state of my servers without me telling it to do anything, really, it kind of tickles the back of my head a little bit and makes me itchy. And because I'm kind of a control freak when it comes to my servers. I want to know what state they're in because I know I'm the one that's going to get paged when something goes wrong on them. Integration tests allow me to build that confidence in my configuration management. I can set up scenarios so that I know, given a certain configuration, when my config management's applied, how is my server going to behave? Is it going to require a reboot when these changes are made? Or is it going to work just fine? Or is it not going to require a reboot because it thinks it's being nice, but it actually does require a reboot because something is just really not behaving right. It didn't specifically ask for a reboot, but it really needs one, right? Because there's those changes, and they're annoying. But the integration tests allow me to build up that degree of confidence before I use that in the production environment or in any other type of environment. So Here's your homework. If you're not already using some sort of CI/CD tool in your environment, or if you're not doing something like this with your automation, pick some sort of source control and CI tools. There's lots of options out there. The reason I recommend Git is most of your source control hosting supports it. If you're going to be working with open source projects, most of them are out on GitHub. GitHub kind of uses Git. If you're going to be doing stuff with VSTS, the default source control there is Git. TFVC, not so much. The TF version control, Team Foundation Server version control, it's kind of out of vogue now. Microsoft recommends Git. Microsoft moved most of its code bases to Git. And so some sort of source control that supports Git is probably a decent idea. Then we want to get our automation checked into that source control and get that CI tool deploying those scripts somewhere where they're usable. Maybe it's packaging stuff up as a module and publishing it to an internal PowerShell Get repository. What the shape of that is, I'll leave it as an exercise to y'all. But if you want to get kind of those foundational behaviors going, start simple. Start easy. Get people used to using source control. Get them used to having that be the mechanism to getting automation available to be used. So, as I said, we got lots of choice. More stuff. You got tools like value stream mapping or current reality trees and all sorts of other crazy tooling out there for figuring out what the flow of work is through your environment and where your constraints are, what the things are that you need to go automate. Learning more about testing, linting and integration tests and unit tests and all the different workflows around that. And always keep an eye on those local optimizations. So with that, more resources, blah, blah, blah. All right. Now I've got a little bit of demo just to show you what a CI pipeline for a PowerShell module might look like. And we'll do this nice and simple. Share content. I need probably, and it looks like I need to add an extension. Oh. Okay, it added, and I want to share my screen. I am now a presenter. All right. So I've already went through and created a little project. And this is in VSTS. Let me make that a little bit bigger. There we go. All right, so let's find our. So this is an early version. I'm working on a more updated version of this. And I'll be blogging about a tool that'll help you scaffold out these pipelines. There's a tool that my team contributes to called, it's a Yeoman generator. Yeoman is a node scaffolding tool. And so we have a generator for Visual Studio Team Services projects. Right now it supports a bunch of different web apps in like Java and Node and .NET and a bunch of different deployment targets. I'm adding in support for PowerShell modules, Chef cookbooks, probably a few other things, DSC resource modules, a couple other things along that route. But that'll probably be out sometime this, maybe February, maybe spring, kind of depends when I can carve a little time. But it'll look something like this, where we have where it pulls the source code for my PowerShell module. I run some static code analysis. That's my linting. That's the PowerShell. That's the PS script analyzer. There's a build script in the PowerShell module that actually has most of the code for this. They'll run our unit tests, publish the test results. So Pester can export its test results in an NUnit format, and most build tools can take and display that visually. So when we'll look at a completed build in just a second, so you can see kind of the build results from it. Then it stages the module for release, bumps the build number, and and it creates the artifact. That gets it ready to release. So again, this would be a little like a kind of a interim, like mid-level release. So it's not your most basic, it's not your most advanced. So our release then looks like there we go. So it takes the artifact that's generated from the build, and first it publishes it to a dev gallery. I have a myget feed. Myget has NuGet hosting, so it publishes my PowerShell module to a myget feed. And that just has the one task. I publish a dev gallery, and then from there, I could add some testing steps here, maybe pull it down locally, play around with it for a little bit. When I'm comfortable with that, I can publish it on then to PowerShell gallery. Now I'm not going to actually publish this module because there's really nothing in it, and but we have a similar task then to publish to the PowerShell gallery. Again, it's just a PowerShell script calling PowerShell get to do the publish module. Really basic stuff, but once it's part of this pipeline, as I make changes, as long as the changes pass my tests, it just rolls on and gets to the publish point where I don't have to manage this anymore. There's a PowerShell module for working with VSTS and TFS called VS Team. And we have it in the pipeline very similar to this, so that when we get contributions and we merge those changes, if it goes through all the tests, it just rolls on out to the PowerShell gallery. And there's no then manual intervention to make that actually happen once all the tests pass. It makes it, when you're dealing internally, you don't have to go out to the PowerShell gallery. You could deploy to an internal gallery. You could deploy to a file share, because PowerShell get works against file shares, right? So there's a very low bar to being able then to create and keep updated PowerShell modules in your organization. All right. With that, any questions? Okay. So I tend to steal ARM templates from like the samples gallery. There's a GitHub repository that's got a bunch of examples, and my use cases tend to be pretty simple because I'm usually building demo environments. When I'm editing them, I usually just use VS Code, and there's a couple of extensions for working with ARM templates. That's what I tend to use. Not really. So I believe Visual Studio has some like right-click, add this kind of resource to your ARM template stuff in it. I haven't used it, so I'm not 100% positive on that, but I seem to recall something like that from a demo. But yeah, usually ARM templates for the most part are pretty handcrafted. You know, the other thing is some people will go through, set things up the way they want through the portal, and then export the ARM template. You can do that. You can do that as much as you want. Yeah, most of my use cases tend to be rather straightforward, so I don't have too many issues starting with the samples. Usually, then it comes into figuring out, okay, how do I copy this thing a bunch of times, and making sure I have all the incrementing done right, so that I get all my, when I'm spinning up 50 of something, then I get 50 of them. Sure. And if you still get stuck, tweet and use the hashtag LOECDA, and my team watches for that, and we'll try to point you in the right direction of any resources we know of. Sure. Other questions? Or do y'all just want to get pizza? Sure. Yeah. Mm-hmm. Well, I mean, are you cloning them down? Is it part of what's getting cloned down? So you should be able to use either copy or publish for them. Is it timing out uploading them to is the published the published artifact timing out? Oh, okay. So MS Build was trying to do something with them. Yeah. Yeah. Right. So the MS Build's probably producing like a zip then after or web deploy package or something. Okay. And can you deploy those files alongside of that, or do they have to be part of the package? If you can deploy that, if you can do them alongside the and not included in the package, because my guess is adding those large files and trying to zip them up is probably what's taking so long with the build. Trying to compress those things down is just you can either copy them to whatever location you're publishing, or add another publish artifact task. Yeah. Or write a PowerShell script. I bet there's somebody in this room that can help you write a little script that will help you copy a file, or robocopy, right? At the end of the day, if you can't make a particular task work, number one, reach out to me either via Twitter or something, and we can talk a little bit more about specifics about looking at the at the task itself to make that work for you. But at the end of the day, all build systems pretty much exist to execute command line tools. And so as long as you can fall back and do something there, you can make it happen in your build. Like the build stuff that I was showing, almost all of it was, there was a build script in the project, and it was just calling functions from that build script, right? All of the logic for the behavior of things, other than like the publish tasks, was in just script that's there, right? So yeah, worst case, fall back, write a little PowerShell, write a little command line to robocopy it or something, get them to the location that gets published, or create another publish task that points to those things, and that should get you around that. Sure. Other questions? Okay. Thank you guys very much.
All right. So before we end the webcast, I just want to thank our sponsors real quick. I want to thank Viewpoint Software for hosting us on the venue, giving us such a great venue. I want to thank Columbia Sportswear for hosting the webcast for us and providing the WebEx. And I want to thank Microsoft and Steve for, of course, your time and for the food. And so we're going to go into kind of an in-person intros and that kind of stuff that we do in person. I won't bother recording it. But if you are on the webcast, there's a good number of people here. We hope that you return. And we hope that anybody on the webcast does decide to come in person at some point and say hi to everybody and have some pizza and have some refreshments. So thanks everybody for coming, and thanks everybody for watching.